Hey guys, welcome to lesson 8, and we are going to talk in this lesson about solving exponential and logarithmic functions. So I want to start off with the property of equality for exponential functions. And so I'm going to write this just an example down. I think it's the best way to explain it. So if I have 3 to the x power equals 3 to the 5th power, well, I already have my bases equal to each other. So if your bases are equal to each other, you can just set your exponents equal to each other. So then I can say x equals 5. So our beginning goal of these, when we go down here, is to make sure that your bases are the same. So this one's already the same, so I can just say x minus 1 equals 2x minus 7, but this one is not. So we're going to talk about that in a second. So let's go back to this one. So since my bases are the same, I'm going to set my exponents equal to each other. And let's see, I'll subtract x and I'll add 7. So x equals 6. This one, I just want to make my bases the same. So notice that they share a common base of 3. So 3 squared is 9. 3 to the 3rd power is 27. So that's where I'm going to start off. And so I'm just changing the way the 9 looks and the 27. And then I'm going to go ahead and just copy down the exponent. So I'm not changing that. I'm not changing anything as far as value goes. I'm just changing the way the 9 looks, and I'm changing the way the 27 looks. So don't forget, when you raise a power to a power, you multiply. So on this side, I have 4x. And this, I'm going to distribute that 3. So I have 3x minus 3. So I'm going to bring that 3x over. So I have x equals negative 3. And that's my answer. So on these two, you can do a couple of different things on this one. So you could change this to a 2 if you wanted to, but I'm just going to keep this as a 4 because 4 to the 3rd power is 64. So I can use 4 as my shared base and do different things with that. Okay, so on this side, I didn't do anything, so I'm just going to leave it alone. But on this side, 4 to what power equals 1 over 64? Well, I know that 4 to the 3rd power equals 64, and because it's a fraction, it's going to be negative 3. So 4 to the negative 3 power is 1 over 64, and then again, I'm just going to keep that exponent. So on this side, I'm really not doing anything. So x minus 4 equals, and then I'm raising this to a power of x minus 6. I'm going to multiply. So negative 3x plus 18. I'm going to add the 3x over here. So I get 4x equals 22. And then divide by 4. So x equals 11 halves, or you could say like 5.5. Doesn't matter. Okay, on this one, so I think I want to have a common base of 5. So I know that 5 squared is 25, so 5 to the negative 2 power is going to be 1 over 25. Let's see, 5 to the 3rd power is going to be 125. And then I'm just going to add my exponents in. And so when you raise a power to a power, you multiply. So this is going to be the same thing as 2 times 5x plus 2 equals 3 times 3x plus 8. So I have negative 10x minus 4 equals 9x plus 24. And then let's see, I'll add this 10 over. So I have 19x equals negative 28. Divide by 19. Ugh, that's not going to be a nice number. So I have x equals negative 28 over 19 for my final answer. Okay, so for this next part, we are going to do something a little bit different. So for these, I want to just notice how these are different. Notice how these both have exponents and they both have a base. Well, these do not. So this is going to be your typical problem. I also can't change this to 3 to some power. It just doesn't work out. So if I had like 81, that would be a 4, so that'd be super easy. But it's not. So that's the difference between these two. So kind of be on the lookout for that. So the first thing that we're going to do is isolate the base and the exponent. So for instance, if I had like 3 to the x plus 1 divided by 2 equals 82, I'm going to get rid of all this junk here until I just isolate that base and exponent. Okay, and the second part is I'm going to change it to a logarithm. So actually this one starts out where we've already changed it to a logarithm. So we're going to talk about that here in a second. And then third, we're going to use that change of base formula so we can use our calculators. So let's start off here. This is not what your original problem will look like. It will look like this. This is just taking it from this step. So notice that if I have a log base 3 of 3, those are inverses of each other. So remember, they're going to cancel each other out. And so my answer is x plus 1. So that's what I'm looking for there. Okay, so for this one, the base is 3. So I'm going to add a log base 3 on both sides. So let me write this out because that looks a little bit sloppy. So I have log base 3 of 3x equals log base 3 of 82. So it's going to look like that. So what happens is that these cancel out, and I'm left with x equals log base 3 of 82. So now this is where that change of base formula comes in. So most calculators, I can't type that into my calculator. So I'm going to have to do the change of base formula. So it's going to be log of 82 over log of 3. So go ahead and type that in your calculator and tell me what you get. Okay, so you should have gotten about 4.011 for that. Okay, so for these are just more practice problems, so really nothing new. I'm just going to add the log base in each of these. So in other words, I'm going to say log base 5 of 5x equals log base 5 of 3. These cancel, and so I get x equals log base 5 of 3. And then I'm going to apply the change of base formula. So this ends up being about 682. Okay, the only difference with this one is that I have to subtract that 1 first. So this goes back to this rule 1, isolate the base. So I'm going to go there and do that first. And then this one is interesting because you could either change the base on this or you could do what we've been doing over here. So I want you to make a choice. I'm going to push pause and then I'll show you both ways. So I did this both ways. So on this one, I just changed the bases so they're the same, and I ended up with 3. This one, I did the log base 2 for both sides, and when I typed that into my calculator, so I did like log base 8 divided by log base 2, and you end up with 3. So that's what I just wanted to point out. Either way is just fine. Same way with this one. So see if you can do that one on your own and see how that turns out. Okay, so for this one, when I subtracted the 1, I got 3. So I looked at it as just like 3 to the first power. So notice my bases were already the same. So you're more than welcome to do, something like this that we did back here. But make it easier on yourself. Like, so you could jump from here to here, which makes it a lot easier. And my answer ended up being 3 again. Okay, these are just more problems. See if you can do these two. Okay, so these are the last two, and in this one, when I subtracted that 6, I got 7 for my answer, and 7 and 4, they don't play well. So I just added the log base 4 to both of them. And so instead of like writing this out here, I did log of 7 divided by log of 4 using the change of base formula, and I got that. So that's where this is showing up here. So I just solved for x, so I added 1 to both sides, and then I divided by 2. So this is my final answer. The second one, or the last one, I guess I should say, this was pretty easy to change to the same base. So 9 is 3 squared, and then I just multiplied these two together. So I had 6x plus 6, and then equals to 2x minus 1. So I thought this one was a lot easier than this one just because it had the common base. Okay, so we are done with the first part of this lesson. There's 3 parts this week. Thanks a lot.